Okay, I'm going to do a quick recap of today's lesson, and I'm going to start with a few problems like we did on Friday where you convert from exponential to log. And if I have 2 to the third is equal to 8, the base is 2, so it'd be log with the base of 2 of 8 is equal to 3. And remember that the answer to a log is actually an exponent. So whenever I look at a log base 2 of 8, I'm looking for what power do I need to accomplish that. 2 to the third power is 8. And then going the other way, if I have log base 3 of 81, it's just 3 to the fourth power is equal to 81. So that's pretty much what we did on Friday. Now, we're going to learn how to graph logs, and we need to review exponential graphs because they are inverses of each other. And in fact, the images of their graphs will be symmetric across the line y is equal to x. And if I know the points on the exponential graph and I want to know the inverse, I can just exchange the x and y coordinate pairs. And I'll be doing that in just a second to show you what that looks like. So if I have an exponential graph and I have a base of 2, I'm going to find the inverse just like I did in the earlier part of this unit, where the first thing I do is I exchange x and y, and then the second thing I do is I solve for y. So when I do that, I would say x is equal to 2 to the y. Now how do I solve for that? It's kind of an interesting situation. I have to rewrite it as a log. So rewrite as a log. So then I have log base 2 of x is equal to y. So this is the inverse log graph of the y is equal to 2 to the x exponential. So let me do another one. X is equal to 3 to the y. I'd rewrite this as log base 3 of x is equal to y. Okay, so let's graph one of these and kind of see what it looks like. If I want to graph the exponential, I would pretty much, I know what it looks like, but I want to get some points to go on there. So I'm going to plug in values -2, -1, 0, 1, 2. So if I have 2 to the -2, that's 1/4. 2 to the -1 is 1 over 2, because it's 1 over 2 to the first. And then 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. So I'm going to plot these points. So -2, I'm at 1/4, then 1/2, then there's my y-intercept, and then at 2 to the first, I have 2, and 2 squared, I am at 4. So generally speaking, that's what my graph looks like. So this is the y is equal to 2 to the x exponential graph. Now, remember I said that it will be reflected across this line, and I'll kind of show you how in just a second. So all I'm going to do here is I'm going to exchange my x and y's. So 1/4 gives me a y of -2, 1/2 gives me a y of -1, and x of 1 would give me a y of 0, and x of 2 would give me a y of 1, and then I also have a 4 and a 2. So I'm going to plot these points. So 1/4, I'll go down by 2. 1/2, I go down by 1. 1 to the right, and that is my x-intercept, which is reflected across the y equals x line. So 2 to the right, I go up 1. 4 to the right, I go up 2. So 1, 2, 3, 4, roughly right about there. And you can see how they are indeed reflected across the line y is equal to x. So I'm going to do some of these with transformations and kind of show you how this is going to look.